So today we're going to be going over parts per million, parts per billion, air and water quality. We're going to do an activity on air quality and water quality in Utah. You need to be turning in your Kool-Aid lab today, and we'll correct assignment 8.3. Now, because there was a sub last time and there were some issues with the sub, and I know there were issues with the sub because the STS told me and one of the other teachers told me, I'm going to take questions before we even start. So, did you get to listen, or not listen, did you get to watch at least the video? Yes. It was basically me just reading the slides and going through the slides. They were just what affects dissolution. So what things help things to dissolve. So it would be making the particle size smaller, changing the temperature of the water, stirring. And I call those my Kool-Aid rules, because if you want to make Kool-Aid fast, you'd use hot water, you'd use powdered sugar, and you'd use to stir it. If you want to make it slow, you'd use cold water, you wouldn't stir it, and you'd use sugar cubes. Okay, so the bigger particles won't dissolve as fast, not stirring it won't dissolve as fast, and making it the water cold wouldn't dissolve as fast. Now, if you want to make it fast, then you do the hot. Is it as nice to drink? Not so much, but, you know, it does work. You can cool it off after. Okay, that's basically all there was last time to the lecture, and you should have been able to get those notes from your lecture. So look at those notes for day 3 and see if there's anything else that you need to know about for day 3 in your notes. And I did put the lecture back up on Canvas so that if you want to go back and look at it, you can. And it does have sound. She just messed up my black box so you can hear it, no matter what you did to the computer. But if you'd have brought it up on your computers, you guys could have. Okay, any other questions on day 3 in your notes? Look at day 3 real quick. Yes? Surface area is how big? So a sugar cube would have small surface area, powdered sugar would have a big surface area. Okay? Anything else on day 3 that you haven't written down that you need to know? No? Okay, then we're going to go into day 4, which, like I said, has these things that we're going to be doing. There we go. We'll correct assignment 8.3 at the end, so hopefully you'll have some chance to, if you didn't get that done, get that done. The objective today is to determine the number of parts per million and parts per billion in various scenarios. Now, this is another thing that'll be used on the ACT. They often talk about parts per million, parts per billion. This is also something that you'll use the rest of your life, because if you have anything to do with air quality or water quality, which is what people worry about around here, is the air quality, and water quality is wherever you go, you need to know what that means. A lot of times, if a company is trying to hide something, they'll report things in pph. Anybody know what that is? That's why they report it in it. It's percent. It's parts per 100. And so if something is in pph, that makes me very nervous, because we want our things in ppb for things like lead and arsenic in our water. We don't want them in parts per 100. We want them in parts per billion. We want itty-bitty amounts, not large amounts. Okay? So we're going to be talking about that kind of stuff today. So, what is concentration and why is it important? What does it mean when something's concentrated? Tell me what you think. What does it mean? Okay, so when some of the water's taken out, so it's like a denser form. Does anybody have another definition that you could use for concentrated? Something pure? Okay. Anything else? Large quantity of something in a certain area. Good. So are we a concentrated class or are we a dilute class? We're more dilute because there are empty spaces between us. To be a concentrated class would fill all the seats. Does that make sense? Okay, so concentrated is something where things are packed together. Okay, so list some everyday items that are packaged in concentrate form that you dilute to use in real life. Bleach, okay. What? Toothpaste. Okay, well, I've never diluted my toothpaste, but dish soap you would dilute, right? Because you put it in a large quantity of water. I don't take my toothpaste and put in a large amount of water before I use it, though. True? Okay, what else? Keep thinking. Some people have it with breakfast every morning. What? No, we really couldn't count cereal as being diluted because we're not going to take it. We put it in milk, so I guess you could sort of say, but it's not really part of the solution. But what about orange juice or juices that you buy in the concentrate form in the cans? Okay, don't you pour that in and then you put 3 or 4 things of water in? So that's diluting. Okay, what about soups? Usually they come in a can and they say add a can of water. Okay, so that's a dilute. So anything that you have to add water to comes in concentrated form. Okay, so you can think of it that way. All right, let's go forward. You can sort of see dilute versus concentrated. You can also visually tell it. We had the orange juice that we talked about. Kool-Aid, like we did last time, comes in concentrated form because we dilute it with water. Plant food, usually it comes in concentrated form and we dilute it with water. Any of the, like, my brain just left, flavors that you put into candy and stuff like that, or like a Milo or a Crystal Light that you squeeze into your water. Okay? Help me. Bouillon cubes, there we go. All right, so pph or percent. When we're thinking of that, it's 1 per 100. So 1 part per 100, or 10 parts per 100, or 12 parts per 100, or 50 parts per 100. So we would say it's 1 pph, or 10 pph, or 12 pph. You would know it's percent. Okay, but in water and air quality, they report it as pph because they don't necessarily want the public knowing that something's getting high in concentration, and most people don't understand what pph is. Okay, it's just ppb, pph, ppm. What are you talking about, right? This is just a way to tell concentration, but know that pph is the same as percent. Okay, and you'd find it the same as you would your percent on the test. ppm and ppb are using the same formula, but instead of timesing it by 100, you're timesing it by 1,000,000. Instead of timesing it by 100, you're timesing it by 1,000,000,000. So 10 to the 6th and 10 to the 9th. So we want things that are pollutants in our water and air to be ppb or even ppt, which is parts per trillion. We don't want them down in the pph. Okay, that can be a hard thing. 1 ppm of chlorine is 5 grams of chlorine in 1 million grams of solution. 5 milligrams of chlorine in 1 million milligrams of solution, or 5 pounds of chlorine in 1 million pounds of solution. So it sort of gives you an idea. There's a lot, there's a little in a lot of space. Okay, but the formula is the same. So part over whole times by 100 for pph times by 10 to the 6th for ppm and times by 10 to the 9th for ppb. So let's describe ppm. The average distance to the moon is about 239 miles, 239,000 miles, or about 1.2 billion feet. So if you jump 1.2 feet in the air, you have jumped 1 part per billion the distance to the moon. Okay. The average distance to the sun is about 93 million miles. When you drive 93 miles, you have driven 1 part per million the distance to the sun. Okay, or if a record or CD sells 1 million copies, then a single record is 1 ppm. So it gives you, ppm is sort of like this large amount that's sort of hard to talk about. So let's do this. What is the percent, which would be pph, of NaCl in a solution made by adding this much to this much of water? Okay, I don't know if I have that example in there or not. You can just write it on the back of the green sheet if you'd like to, or just on some white sheet area. So the way that we would go about doing this is we'd just say 43, because that's what we're putting in of salt, divided by, and here you've got to have the total mass on the bottom. So 43 plus 157 on the bottom. So the bottom has to be the total amount. So it's sort of like finding your percent on the test, but you got to know the total of the test. Times by, since we're doing pph, times by 100. So if you haven't got a calculator, come up and get one because you're going to need one today. And let's try this and see what we get. So who needs a calculator? Calculator, calculator. Calculator, you got one. Calculator. Calculator, you got one. You got one. Calculator, you got one. Okay, what do we get for an answer? So, 21.5. I was going to put percent, but I need to put pph. Okay, 21.5. Do I have a second on that? Yes? Okay, so let's do this next one. How many grams of HCl are needed to mix 500 grams of a 150 parts per million solution? So this time we're looking for this, where the 43 was up on here, we're looking for that number down here. But they gave us, this is the total, so I don't have to add it up. That's how much I want as a total solution. So I'm going to have x divided by 500 times by part per million. What did I tell you that was times by? 10 to the 6th. 10 to the 6th equals 150 parts per million. Okay, step by step, what do I do first? I need to divide both sides by what? Or times both sides by what? Okay, let's times both sides by 500. So if I times both sides by 500, over here the 500s cancel, right? Then I get 10 to the 6th x equals, what are these two times together? 75,000. Okay, now what do I do? Second step. Divide by 10 to the 6th. Over here, I'll put it twice. Over here, the 10 to the 6th will cancel. Over here, we end up with x equals what? 7.5 times 10 to the what? 3, 4 minus 2? 0.07. Right. Okay, so 0.075, right? Okay, that's 1, 2 in the negative direction, so that would be the scientific notation, or you could write it this way. So either way, and that's how many grams that I would need of AgCl. Okay, so take it in 2 steps. If you have to take it in 2 steps, do it that way. If you can see right away what you need to do, that's awesome. So here it says, what is the concentration of Ag plus ions in the previous solution? Well, this splits here and here. It goes Ag plus and Cl minus, right? Since it's 1, I can say it's 150 parts per million, because it's the same. If it had been like BaCl2 and they asked for the Cl, and there's 2 of them, I would times that number by 2. Okay, yes? That's just what the number is when I write it not in scientific notation. So 0.075 is this number. This one? 10 to the 6th. My marker just skipped. Okay, let's go forward, maybe. Oh, okay, I'm going to pause this one for a minute, what a million is. So I've got a little thing here, hopefully. Oh, just a second. We're going to go to another. Swimming in what did he say? Toilet bowl. So I just think there's no point to going all the way to the bathroom, right? That's what some of the people think. So in the episode of The Big Bang Theory, Sheldon freaked out because of pee in the pool. Why? Given there are 18 parts per million of urine in an Olympic-sized swimming pool, how many milliliters is that if this pool contains a total of 2,500,000, try that again. Anyway, 2,500,000 liters of solution. So this would be like what we did before, where we say, okay, how many in 2,500,000 times 10 to the, we were parts per million, right? 6 equals 18. Okay, so that's liters, and they're asking how many milliliters. So let's find liters first. So what do we do? What would be the first thing you would want to do? Let's times both sides by the 2,500,000. Okay, over here it would cancel. Over here we'd get 10 to the 6, x equals, and what would be the number? What? Do 4.5 times what? 8. Okay, then we're going to divide both sides by 10 to the 6th, right? Well, all we have to do is subtract the exponents here. So x is equal to 4.5 times 10 to the 2nd. That's liters. So is equal to 450 liters. So if we do milliliters, we times that by 1,000. That's a lot of pee in a pool. That's why he's freaking out. Okay, so let's let's listen to something else. I'm not trying to make you not ever want to go swim in a pool again, okay? But you need to know what's going on. Come on, go forward. Just thinking about it. Oh, don't do that. We want to listen to this one. See if I can bring it up. Summarize and say, you know that smell that you smell that reminds you of a swimming pool when you walk in the door? Chlorine doesn't have a smell. What that is chlorine reacting with pee. That's the smell that you relate to swimming pool. So, and it just goes through and talks about how much pee is in all the different pools and how they tested many swimming pools, public and private, and how much pee is actually in there. So anyway, we'll go ahead and go forward. So, and I'll try and bring that up towards the end because it's pretty cool. I mean, not cool, it's sort of gross, but you get an idea. Yeah.
I got a quick question on the last problem. Where'd you get the 6?
Where'd I get what? That's million. So, whoops. So when you're, okay, it's thinking about it, maybe. You can see it for a second. That 10 to the 6 that flashed up there, that is the million. So if I'm getting parts per million, I'm timesing by a million. If I'm getting parts per billion, I times by 10 to the 9th. If I'm doing parts per 100, I times by 100. Okay? All right, so let's do this next one. Given that there's one blue marble in that many marbles, what's the parts per billion of the blue marble? So setting it up, 1, come on. Why is it not talking to me now? It doesn't love me. Okay, we're going to stop. Okay, so you're going to just take 1 divided by 4, 5, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay? Yes. Yes.
For the droppers, they can't get the stuff out.
They
The
can't.
test tubes
Oh,
they have,
just tip them.
it's not enough.
Really?
So are we okay to use the smaller ones?
Yeah, I didn't think we had very many of the smaller ones, though.
But But the big ones, a lot of them, some of them are fine, but some of them are too tall to use the.
Okay.
So.
All right. Well, it'll make do. Okay. So then we're going to take and times this by what? 10 to the 9th, because we want parts per billion, right? And we get our answer. So if I look at this, this one is actually 4.5 times 10 to the 3, 6, 9, 12, 13. That helps me put it in, so I don't have to worry about all the zeros. So the 9 and the 13 would cancel, leaving me a 4 down here. So 1 divided by 4.5 times 10 to the 4th. So that's going to be really small, right? We're going to end up with times 10 to the negative up here, something. Or 0.000 something. What do we get? You got an answer? Be brave. Should be like 2 point something or 3 point something. I'm looking at 1 divided by 4, 1 divided by 5. Should be between 0.25 and, we don't know. Make sure you put your thing in parentheses, and I cannot read this, it's too little.
Isn't it
0.00022. One more O. Yep, it would be at least 4 O's. 2, like that. So basically that would be 2.2 times 10 to the 1, 2, 3, 4, 5, negative 5. Okay. I've got to figure out how to. By the way, we were playing with these the other day and found a whole bunch of your things already saved underneath. Let me see if I can remember what it was. Constants, second constants. So there's a speed of light underneath there. There's Planck's constant. There's Avogadro's number, ideal gas constant, proton mass, electron mass, neutron mass, universal gravity. There's tons of stuff in there. It just keeps going and going. So there's a lot of constants already in that we found the other day. All right, so let's do this next one. Given that there is that much lead and that much water, what's the parts per million? So 0.0007, one more 0, 7, divided by 10, 1, 2, 3, 1, 2, 3, 1, 2, 3, times 10 to the million is what? 10 to the 6th equals. What do we get? And I should have put over here ppb. What are we going to end up with, guys? Yes? 9 and the 13th, I was just doing math. When you have exponents, you can subtract them when they're divided. Yes?
There's
8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then what? A 7. So 7.0 times 10 to the negative 9, good. Parts per million, lead. Okay, good. Not too hard, right? Takes a little math, but not too bad. Okay, going forward, We're going to do some water quality stuff. If you need to grab a computer, grab a computer. If not, grab your phone. We're going to do some just really quick, and it went away. Love this. Put this on so we can have it. You're going to do some really quick research with the partner that's next to you. I want you to research water quality. Find out what you can about the water quality here in Layton, in Clearfield, in West Basin, or Weber Basin, in Syracuse, wherever you live, between you and your partner. Find out where do you go to find the water quality for your city, and see what you can find out about it. We'll come back together here in just a minute. Who's brave? Who would like to share what they found out? Did you find out anything exciting, disgusting? Yeah.
So we were looking at like putting out three contaminations that can cause cancer because of like pollution and stuff.
Okay, what were the contaminations?
Chromium,
Chromium, hexa, what?
hexavalent, and
Vanadium, probably.
radiological contaminants and
Trihalogen methanes, okay? That just means a carbon with 3 halogens around it instead of 4 hydrogens. Okay, so that's sort of scary, right? Okay, anybody else find anything else? Yes?
What's the stuff that can cause stuff from soil runoff? So that's like think that your water's all clean, but it has like dirt and stuff probably.
Has dirt and stuff in it because they're constantly digging up pipes and replacing, right? Okay, what else did you find out? Have you ever gone to somewhere else and drank the water and got sick? It's because you're used to the bugs in your area and not used to them in other places. Okay, was it hard? Yeah, go ahead.
I was looking at like Layton,
At Layton's, okay.
and it said there's like inorganic contaminants, and one of them said that there's like it's from the contaminants are from discharge of drilling waste and metal burners of steel and coal mills.
Okay, so there's stuff in your water and you got to be aware of it. Now, how many times do you think you ought to look at this report? How many times does it come out? It does come out every year. So you can do what we did. We took, what, 8 minutes and just taken a second and look at your water report. If you become a homeowner, they're supposed to send that to you or send you a link so that you can find your water report online. So what happens if, like in Clinton I think it was 2 years ago or maybe last year, they had an E. coli breakout.
Ooh, that sounds good.
There was E. coli in the water. What did they do? What did the people that were in charge do? Yes.
Well, they should kind of like hold a water system to mine in like my area because that was where it all was.
Okay.
I could get from bottled water. I got so sick of it that on the last day when they said that it was safe to drink, but like you should be warm to drink much safer, and then got really sick the next day. My mom's like, "See, use your pulse liver."
So, and they told them to boil the water that you were going to use, right?
I think that's nasty.
Okay. Did you have something you wanted to add? Okay, so, but what happened in the stores around that? Do you remember?
All the water was like, in like all the stores like out of water.
Like within seconds it was panic. It was pandemonium. People went to the store and were buying water bottles like crazy, and they had to put limits on it. You can only get 2 things of water, or you can only get, and it was really crazy. So, best way to inform people of a contamination. That's fine. So if something's contaminated, what do you think? If you were the public water person and all of a sudden you found out there was a problem.
Newspaper, radio.
Yeah, but do you want to send everybody in panic? When do you tell them?
When it started to like read it.
Okay, so isn't there a city back east that everybody's been hearing about that has lead in their water?
Michigan.
Okay, and does anybody want to move there anymore?
No.
Everybody trying to get out of there?
Yeah.
Okay, so you can cause a lot of problems by announcing something before it's really an issue. Does that make sense? And you try and fix it. So who should be responsible for notifying the public?
The city, that is,
The city that's in it? Okay. And what are the possible effects? We talked about releasing the information. There can be a run on the store for bottled water. There can be pandemonium, people trying to get out of your city, nobody wanting to go in. And if you lose too many from your city, you lose the revenue to fix the problem, right? So there's a lot of things that could go wrong. Okay, let's go on a little bit more. So when we talk about air quality, this is a big problem in Utah. We can go to several different places. Hopefully it will hot link here like it's supposed to. Maybe it won't. I love when it does what it's not supposed to do. Let's try this link and see if it'll go.
those are red ones.
They're all supposed to be links, but they're not working. Okay, let me see if I can do it with the mouse over here. Oh, they're coming over onto this other side. Okay, so there's a couple places that you can look. Air Now is one that you can actually look all over the country, and it tells you what's going on. You can see Las Vegas has some moderate and some unhealthy going on here, but you can actually go all over and look at the forecast and more maps. So this one is called Air Now. The other one is more local. Whoops, went the wrong way. Let's try and bring it up again. I keep bringing up Air Now. Let's go back. There we are. There's KSL. It was the smokestacks. Okay, so in KSL, you can actually go where it is, where we live, and you can actually see. And right now, we're all in green. Why do you think it's all green? What happened last night? We had a lot of wind, right? It blew everything out. But you can go up and down and all over and look and see. What does it look like? Pocatello actually is moderate unhealthy right now. And you can go out, and that's as far as they actually do. So you can actually go within one area. So if we came in here, and let's pick this one, South Weaver, you can actually go in real time and see what their running averages were for pollution. So this air quality is pretty good. So for the week 1, 24 hours, last hour, pretty good. As we go down to air quality resource, we've also got UCARE, Utah Clean Air Act, and it goes through different things like this. What I would like you to do is I would like you to now take the next 10 minutes and just research Utah Air and how it's happened the last little bit, what the quality means, what does the numbers mean, where does it split, what do the colors mean, what kind of things can you find out about Utah air quality. And if you go to KSL, like I said, down at the bottom, there is these things that you can actually go to. You can actually even buy an air quality station if you really want to. Okay, this gives you a little bit of information here. You can also look at the station lists and stuff like that. But I want you to take a few minutes and just sort of explore the air quality. So we'll go on to this next one. Remember what I had here linked. Oh, and you can also go on to the Department of Environmental Quality, and it'll actually go into a little bit more in depth right here, and you can actually find your city. Oh, it didn't go to where I wanted it to go. That's right here, that's why. So we're in Davis County, and we can go and actually look at Davis County parts per million. These are particulates, and how many small particulates we have, and what does that mean, and it goes into a little bit more stuff down below here. So I'll give you a few minutes to go ahead and research. Where did it go? I don't know which one it's on. No. This one. Okay, I'm going to bring you back together. I know it hasn't been very long, but let's go over this really quickly. This one was one that the air quality index, and you could look up AQI anywhere, and it's the same. This sort of gives you particulate matter. This is stuff we're worried about, small particles that get stuck in the lungs that cause growth and cancer. And ozone also can cause oxidation, stuff going on in your body that you don't want. You can sort of see where things are. We don't want to ever get really above the moderate. But we in Utah have had some what they call red days, and that's the unhealthy days. Orange days are the sensitive for small groups. But again, you can check this every day, yes.
On red days, we're not really supposed to go outside.
Right. They're not supposed to do any physical activity because it can actually bring in more particulates. You can see that they're very high there. Yes, we've had a couple days. No. Okay, so we're going to do a little activity. And the activity has to do with doing parts per million and what it actually looks like visually. And it is in your assignment sheets. So we should be through with what is on day 4. What I'm going to do is I'm going to give you a color, and you're going to go grab the stuff that you need. Okay, I have got some little beakers and I've got some big beakers up here just because of what Mrs. Roberts said. You might have problems with the micropipettes. So if you have to, after you mix it, you can pour it into a beaker. Take a dropper full out of the beaker, pour it back in the test tube so you can see the colors. Okay, those are what those are for. The bigger beakers are for your water, and you've got pipettes and coloring things. So this row right here, everybody look at me in this row. Orange, blue, orange, blue. Okay, red, green, green. Orange, blue, red, green, orange, blue, red, green. Okay, you're working in a group of 4 or 3, and you're doing it. So you were red. So whatever red does, it's what you're doing. So come up and get what you need. Work in a group. As far as the large piece of white paper, just use a white piece of paper. You just need the color behind it, okay? Come do it. Stuff is up here. Come get what you need. If you're in charge of getting the water, get the water. So you'll need a big beaker and a small beaker. The big beaker is what you're going to fill the water with. So if you're in charge of the water, if you're in charge of the, oh, and I didn't put coffee stirrers out. Coffee stirrers will be over here. So if you're in charge of coffee stirrers, come over here. That would be green. So if you're green, come over here and get your coffee stirrer. And I am going to have to spread that out because we're going to have that problem next period really bad.
Wait, what do you put on dark violet?
On hazardous to health of all. Deadly.
Are these the beakers?
Yep. So the big one you fill full of water.
All the way?
Yep, because you're going to be using it to dilute everything.
Chlorine poison.
Chlorine is chlorate can be. Chlorate can cause lots of problems. It's an oxidizer.
It's kind of weed killer.
Mm-hmm. Yeah. Okay, get with your group of 4 as fast as you can. You're going to need to dilute. Like this group. 4. So you should have 1 of each color in your group.
Is this the one that we put the food coloring in?
So this is you're going to put the water in,
Oh.
and the food coloring actually goes into your test tubes. So somebody that orange, you're picking up not 8 beakers, but you're picking up the thing of test tubes.
So we don't fill this.
You fill the big beaker full of water. Sorry, I'm going to have to fix this. You only need 1.
What about red? What's a micro?
Okay, so red, that's just the dropper.
Taking this entire thing, right?
Okay, and you're getting the small beaker, and you're getting Food coloring.
We're taking this entire thing.
Yep, you're taking the whole thing.
Okay, so red tartini small.
So you need so red needs the dropper and a micropipette and a small beaker. Whoa, sorry.
So no, it's
The big beaker is going to be blue. Whoa.
Oh, sorry, I did your question again.
Yeah, it's very touchy.
so 10 drops.
I should go like this.
Doesn't matter what color.
Doesn't matter what color. No, it doesn't matter what color.
Okay, so it's not under here. Let's see. You got one micro pipe and a beaker with 10 drops. Okay.
Is it the small beaker or the big one?
Small beaker.
All right.
Wait, red is the small beaker?
Yes. And get out a piece of white paper. Sorry. Got to fix a little few of these. Yeah, just something you can compare, put that against, so it has a white background. Okay, so what you're going to do, this person right here, red, you're going to take in with the food coloring, put 10 drops in that beaker, with, and then you're going to put the food coloring back. Okay. 10. And then follow what it tells you to do. The test tubes are your small beakers because we don't have enough of them. But if you need to pour it back into another small beaker, there's some more small beakers up here. I probably should have had you pick up two. I'm going to come back around and give you another beaker. Okay, you're going to have to probably turn around and be on this middle one right here so everybody can work together. Okay, get going, do what it tells you to do. Follow the activity. Maybe pull your stuff around here and, oh, let me just follow, okay? Just because it's fun. It's in your assignment sheet. Starts here.
So if we just added drops with it, one beaker and drop.
So the beakers, when it's talks about beakers, it's test tubes. And then the small beaker that you don't use to start, you can use to put your stuff out to be able to suck up the thing, because she says that they were having problems with the test tubes. I'm going to spread these out a little bit more.
So if we just pour one drop of food coloring in water and leave the rest of it?
I don't know, follow instructions.
It says, all right, which one? One and two.
Oh.
There's your beakers.
Yep. All right, so let's say this one's beaker one.
So these are going to be your beakers, okay, as you go. So you only need one color, okay. Safe to drink, blah, 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 blah. So for your group, obtain the materials, blah. Place one drop from beaker one. So beaker one, we were supposed to be right here where we took 10 drops of red. So place one drop from beaker one into this one, and then 9 drops of water. And then you're going to shake that up, pour it into here, so you can then take drops, put it in here, and put that back.
That's right.
Okay.
Okay, wait. So then like one in here and then 10 drops of water.
Mm-hmm.
Okay.
Nope, 9 drops of water.
And the next one would be 2, then 3, then 4, then 5. I am so confused.
So then you're going to take the stuff from beaker 2 that you made and put 1 drop of that into beaker 2 and then add 9 drops of water. So you're diluting it as you're going.
First,
Right.
then okay.
Okay?
the 9 drops.
Okay, we only have about 7 minutes, so you got to get the dilution going quickly, guys.
Oh,
So somebody's going to be in charge of the water and somebody else in charge of the other.
like I did.
Please one drop.
So you got a second beaker, second small beaker? You need 1 drop of your dye. Do you have your dye? Okay, so you're going to pour 1 drop of that into your second beaker. And there's a beaker because she said they were having problems. Yeah. You might have to rinse that beaker out in between. Does that make sense? So it doesn't get contaminated. You just need 1 drop of that, so you'll be good. No, don't rinse that out. You're going to rinse the beaker out because you're going to pour that back in. Because you got to have a... Okay, now put it back in there because you're going to look at the whole thing as you go. Does that make sense? So now you're going to pour that back in here. You just had to do it because our pipettes are not long enough. And now add 9 drops of water to that. So that one just goes as the original, so you can see what the original looked like. Okay, now see what you did with your beaker of water? You've now contaminated it. So you actually need 2 droppers, 1 just for water and 1 just for moving the solution. So rinse that out. Okay, you have 5 minutes, guys.
Wait, in the first speaker you do 10 drops?
Just 10 drops of the color.
Oh, I knew it.
Okay, so.
So this all should go in here. So
Oh.
it's your beginning. So what did you do in here?
I only did 1 drop.
Okay, so that's actually that one.
Okay.
So this is your first one. You're just doing it so you can compare the colors as you go. Now, then go rinse that out really quick. You're going to need rinse, yep. So what you do now is you take this, and if you can't get the drop, you put it down in here, get your drop, put it in here, pour this back in here, then rinse that out again. Okay? So do this fast because you're running out of time. So 1 drop, 9 drops, and then just use this to suck up and put back.
9 drops and 3?
Yep. Go rinse that out. And then you'll pour that one into here. Take 1 drop, put it back in. Does that make sense? Yep, pour it into there. I don't think we're going to need the stirs. Okay, yes. So every time we just add a 0.
This towel,
Yep.
why?
Mhm.
So,
shut this one else. Uploaded everything. Okay, Stacy, I am ready to kill somebody. I have published it. It's unlocked. I've got a module under biology. They can see it, and it keeps saying that it's not published.